Hi, graded students. So let me discuss to you about relations and functions. So for this introduction, this is just a recall. The standard form of the equation of the line is ax plus by equals c. Remember that, and to graph a line, you need to find ordered pairs x, y that will satisfy the given equation. Hence, there is a relation that exists between these two elements that one may be dependent to the other, right? So x can be dependent by y, or y can be dependent from x. So the first element x of the ordered pair is called the abscissa. Recalled? Okay. And the second element y is called the ordinate. So x, y, abscissa and ordinate. And the set of abscissa is the domain, and the set of ordinate is the range. So we'll give later. The relation is a set of ordered pairs. Take note of the relation, meaning relation or definition is a set of ordered pairs. Okay. Now, a relation between the domain and the range can be presented in different ways. And later on, or in another video, I'll be presenting different ways, okay, how we can present relation. So this time, we're going to present relation by set of ordered pairs, and also by arrow diagram. So let's see. So let's define first relation. What a relation is. Relation is any set of ordered pairs given by example. Okay, so ordered pairs 0, 0, 1, 1, 1, 2, 1, 2, 3, and 3, 4. Okay, it is a set. Next, how about a domain of the relation? So when we talk about domain of the relation, it is a set of first coordinates of the ordered pairs. So we all know that the first coordinates of the ordered pairs is called abscissa, the set of all abscissas. Okay, set of all x. So we have here the relation 0, 0, 1, 1, 1, 2, 2, 3, 3, 4. So what are the x coordinates? So we have 0, 1, 2, 3. So notice that there are 5 ordered pairs, but we only have 4 elements in the domain. Why? Because 1 is repeated twice. So we just count it as 1 as we write it in the domain. So we only have 0, 1, 2, 3. We cannot write it 0, 1, 1, 2, 3. No, because remember in your 7th grade that an element must be unique. Okay, an element of a set must be unique. So 1 is the same with 1. So you write it as 1. So where did it came from? All the first element of the ordered pairs. Okay, let's continue. How about the range? If domain is the set of first coordinates, range is the set of second coordinates of the ordered pairs. So again, if this is the relation, what will be our range? Okay, you notice there are only 3 elements of range. Why? Because 1 is repeated 4 times. So we only have 0, 1, and 6 as elements of our range, or the set of second coordinates of the ordered pairs. Okay? Easy for the domain and range, right? Proceed. Now, if a relation is any set of ordered pairs, a function is a relation with a specific condition, wherein a relation in which each element in the domain is mapped exactly one element in the range. So this is the condition for a relation to become a function, that each element of the domain or the set of all abscissas is mapped exactly one element in the range. Okay, let's take a look with this example. 0, 0, 1, 1, 2, 1, 3, 1, 4, 1, and 5, 6. So what will be the function, what makes it a function? Because 0 is mapped to 0 alone, 1 is mapped to 1, 2 is mapped to 1, 3 is mapped to 1, 4 is mapped to 1, and 5 is mapped to 6. There is no repetition of element in the domain. 0, 1, 2, 3, 4, 5. Okay? So, it is a function. Just always follow the condition. See, just look at the condition. Okay, an element in the domain is mapped exactly one element in the range. Or in simple terms, there's no repetition of element in domain. So the domain is 0, 1, 2, 3, 4, 5. 5 ordered pairs, 5 elements of set in domain. So it is a function. So let's identify functions. How are we going to identify functions? So let's take a look for this two input and outputs example for letter A and B. So here's the instruction. Decide whether the relation is a function. If so, give the domain and the range. So I think I also give the domain and range whether it is a function or not. So let's keep on answering this. So for letter A, as you can see, we have the column of input and output. And we can say that the relation is a function. Why? Because for each input 1, there is only one output. 1, 2, 2, 4, 3, 4, and 4 to 5. So there is only one output in each input. So it is a function. And the domain will be the set of all first elements or first coordinates. We have 1, 2, 3, 4, and the second one is 2, 4, 5. How about letter B? It is not a function. Why? Because looking at the input 1, it has two outputs which are 5 and 7. So therefore, this is not a function. Take note of the definition, condition of a relation that is a function, that one element of the domain must be map exactly one to the domain to the second element. So the domain 1, 2, 3, 4, and the range is 5, 7, 9. So that's it. So if we're going to recall for our conclusion, just recall this. Okay, that will be all. Okay, so just recall what is domain, relation, range, and function, and how to identify um, function. That's all. Goodbye.